this will be different in a sense. We're on to chapter 8 now, which kind of puts conversions on hold and kind of comes back to looking at reactions and formulas again. And then chapter 9 is essentially merging those two things together. So looking at balanced reactions and then doing some conversions with them. So we're taking these two things and switching them together eventually. That's the role we get on. Maybe we'll get to a couple of those before we switch for the semester, but my guess is that we'll spend most of the time trying to finish up chapter 8 before we get to chapter 9. So you will have, most of the people in here did pretty well in the last test. You'll have one more opportunity to get a test grade into the computer before semester time, and then these study for the finals. This will take us a couple weeks, maybe a little bit less than that, and then we'll have 3 or 4 days, probably 3 days to study for finals, work on a cheat sheet, do some review stuff in class, that kind of thing, and it'll take fun. Okay, and then move on here, break the band up a little bit. So this section is about, we'll call it, it's sort of 8.1 and 8.2, and it's let's call it balancing reactions. A reaction pretty much looks the same. In a typical reaction, things on the left side of the arrow are called the reactants. Things on the right side of the arrow are called products. From a while back, sometimes it takes energy to make products from reactants, and sometimes you make products and it gives off energy and exothermic. So there's some sort of energy transfer when you're doing every chemical reaction. If the reaction requires heat, sometimes some other things you'll see with reactions is that if it requires heat, we'll put a little triangle here. You might see those on some of the reactions you look at today. That just means that the reaction needs heat to happen. You have to heat the reactants. Sometimes if the reaction produces energy, not all the time, but sometimes people will write out energy here, that it gives off energy, or it might require energy. But those are some of the more basic things you'll see with the reaction. Sometimes in reactions you'll see people put the state of matter, so that can get kind of confusing. I tend to shy away from that, but if you're doing H2O, let's say, decomposing to make H2 and O2. Sometimes people will write the states, solid, liquid, gas on these, and that can get kind of tedious. So if we do liquid, we write L in parentheses, and if it makes H2 and O2, those would both be gases here and a G in parentheses. I tend to stay away from that, but that's what that means in case you see that. Just for the sake of speed, I tend to not do that so much, but those are the common things you see with reactions. Probably things you've seen before. When we talk about reactions, we get into something we already talked about, which is conservation of mass. In every chemical or physical change, mass is going to be conserved, so you don't lose anything or gain anything in any chemical or physical change. So it's going to write any P&C change mass is conserved. So in one of my examples already, this one, we've got a problem. Okay, if mass is conserved, how does we've got 2 hydrogens on the left side of this reaction, on the reactant side. So we've got 2 hydrogens here, so that's conserved, right? It's the same number. But on this side of the reaction, we've got how many oxygens? 1. How many do we have here? 2. And so the way that's written right now is that one of those oxygens magically appeared from Hogwarts. I'm not Potter familiar. We could say it appeared from the Shire or Eelsildor, because I'm very Lord of the Rings familiar. Probably too familiar. Anyway, the idea is that this is not written the correct way. Okay? And you have got one thing here, and you have to have one thing here, or 2 and 2. They have to match, essentially. You can't make something from nothing, and you can't send something to nowhere. So we call that, the way that we fix that problem is we balance reactions. Can I erase now? Have you written what is written? Is that a yes? Great, good talk. This has been really good. Thanks for being so vocal.
Sometimes you get angry when
we talk, you don't like it.
If I ask you a question, you can go ahead and answer it.
My answer was going to be very
Very snide.
Smart alecky.
That's okay. Was it Lord of the Rings related?
Yes.
See, then I don't like it. It's gonna play to your strengths. You know? All right. So the way that we fix that problem, or the way that we represent the conservation of mass reactions, is we have to balance it. Okay? Balancing is something that's going to happen all the time. So probably already written. Let's just stick with that one for example. When we have this H2O decomposing to make hydrogen and oxygen. This is called a skeleton reaction. This is what happens, okay? Water will decompose to make those two things. But the skeleton reaction does not balance it. So it's not showing you exactly what's happening. It shows you that you've got one reactant, that's water, and if you let it sit by itself, it will break up into hydrogen and oxygen. Actually, put some work into it. But it's not showing you exactly how it works, okay? And the way that you know that is because you've only got one oxygen here, you've got two there, and that's impossible. You can't just make a second oxygen. So balancing is something that we could have been doing this entire time, but it's just showing it to you now about to kind of more accurately represent what's going on with reactions. The way that you balance, I know that last chapter we got into lots of steps. Okay, this chapter for balancing is sort of more open-ended. It's sort of trial and error-ish. When you balance stuff, you only put coefficients here in front of the compound. Okay, you never touch anything that is a formula. So you are not allowed to touch what's going on there. If you change the two, if you change this two or that two or that two, you're doing something wrong. Okay? When you balance reactions, all you do is you put whole number coefficients in front on those purple lines to balance out the number of atoms of each element. You can do that with a table, and I'm going to start with a table because it's sort of helpful and people seem to like that. But a table gets kind of tedious, and I'm going to stop using it in a second. But it's just to show you an example, a running example of what kind of goes on in your head. I'll show you the table. The table looks like this. You got reactants, you got products, and we've only got two elements there. What elements are in that equation? Hydrogen is one of them. Oxygen's another. Okay. On the reactant side, how many hydrogens do you have? Two. Okay. And you've got how many oxygens on the reactant side? One. On the product side is where you run into a problem because you've got two hydrogens, but you've also got two oxygens. For the reaction to be balanced, obviously these numbers need to match up. Okay. Now again, if you want to do it this way, that's great. I would suggest it. It's cool. It's a nice way to keep kind of a running total of what's going on. But again, I'll do it a couple times, but it gets kind of too much for me. Okay, so the way that you do that is you start putting numbers in front. The nice part about balancing reactions is you can pick anywhere to start. And if it doesn't work out, you can erase with your magic eraser finger, or you can use your colored pencil to erase. I'm going to start. If you essentially hydrogen's already done, so let's start at oxygen and then go from there. Okay. So the way that you do that is you put a number in front there. You've got one oxygen here, you've got two oxygens there. So what number could I put in front that would distribute to give me two oxygens? Yeah, 2, right? It distributes like a parenthesis number. So I'm going to put a 2 here. The 2 distributes to everything. So right now, I just gave myself 2 oxygens, but what else did I do? That 2 distributes to everything. Okay? So the 2 distributes to also this H, and we've already got 2 of them, so 2 times 2 is what? 4, good answer. So I've already given myself 4 hydrogens. Okay, so I fixed this problem, but I created another problem, and that now my hydrogens don't match up. But that is easier to fix now because I can put what number here to give me 4 hydrogens? 2. Okay, so you see how this is working. Put a 2 here, and that gives you 4 hydrogens, and now everything is matched up. So this, with the 2's in front there, those coefficients, that's said to be a balanced reaction. I'll rewrite it here so you can see it. 2 H2O's decomposes to make 2 hydrogen gases and 1 oxygen molecule. Now it correctly reflects on a molecular and a molar level what's going on with this reaction. 2 of these, this is literally what happens, 2 hydrogen or 2 water molecules will decompose to make 2 hydrogen atoms and 1 oxygen. If there's no number in front of there, it means 1. Okay. So this is called a balanced complete reaction. It shows you on both molecular level that 2 of these will make 2 of these and 1 of these. And it also shows you on a molar level. 2 moles of this will always make 2 moles of this and 1 mole of that. Okay. And it's balanced, which is the important part. Okay. Questions about that? Want to try another one? I think fun. No? No? What? Should we just start with easy ones? Or do you want to ramp it up?
Ramp it up.
Okay. What do you think? What do you think?
Old nitride. Oh, that's tricky.
Okay. Wow. Let's stick to the table. This is the last one. Let's stick to the table. It's going to be kind of a serious table. Now there are some hints that will help you out here for balancing reactions. I know that we said there's it's kind of a trial and error process, but there are a couple of things that will help you, and I'll kind of point some of them out here for you. What do we have here? We've got barium, we've got chlorine, we've got silver, and we've got nitrate. Now here's one of the hints. Treat this nitrate as one thing, okay? Very rarely will this NO3 be broken up over here. So you can treat it as one element. It makes your life a whole lot easier, okay? Otherwise, treat all the elements individually, but when you have things off of the yellow sheet, almost always you can treat them as one thing. That will make your life somewhat simpler. Okay? That's one hand. So I'm treating it as one thing here. I've got on the reactant side, I've got 1 barium, 2 chlorines, 1 silver, 1 nitrate. On the product side, I've got 1 barium, 2 nitrates, 1 silver, and 1 chlorine. So there's a couple things that don't match up here. You can, as I said again, pick any spot to start, but it's probably best to start at a spot that doesn't match up. Okay? And you'll notice when you do these, it's kind of this back and forth, where you start on one side, and that affects something else, so you bounce over here, and then that affects something else. So there's kind of this back and forth when you're kind of balancing things out. I'm going to start at, I don't know, let's just do chlorine, because I can see it's the first one here. There's 2 chlorines right here. How many chlorines are over there? 1. So the way that you fix that is you put a 2 out in front here. Okay? I'll just use red. And when you do that, it affects other things. So now we just fixed the chlorine problem. I've got 2 of them, but it also created a new problem, right? So my silver's got 2, because the number distributes to everything. So on this product side, I've also got 2 silvers. Okay, that's fine. But you see, once you change the silver, now let's go back, let's fix this silver. Okay, so I've got 2 silvers here. I want to have 2 here. Remember, the only thing you can do is put numbers in front, and the number distributes to everything. So I just gave myself 2 silvers, and what else did I give myself? 2 nitrates, right? So I got 2 nitrates now. And now look, magically, numbers have matched up. It's not really magic, it's more like math, but. So if the table helps you, great. That's probably the last example I'll show you the table. But it's a nice way to keep track of what's going on. But did you see how I started here, and then put a number here, bounce back here, put a number there, and then I could have bounced back there, but it was already done. You'll kind of have this back and forth where you do that, because the numbers you put in front, remember, affect everything. So it gives you 2 silvers, it also gives you 2 nitrates. Okay? That's the important part. Notice I changed nothing of the formulas. You are only allowed to put numbers in the spaces in front. Okay? That's the only thing you can do. So it makes it easy in a sense that it's sort of like a puzzle, every one of them, but don't ever change the formulas, because, or try and squeeze numbers in here. You can't put a 2 here, you can't put a 2 there. It's not how it works, it changes everything. So that's not balancing, that's cheating. Sort of. Want to see some other ones? Isn't this fun, balancing steps? No? Are you guys done? No? Okay. Let's do...
Howard Shore. That's part of that movie right there.
What happened?
He's the guy who wrote the music.
What music?
For Lord of the Rings.
Alright. I'm not talking about the movie, I'm talking about the book. I'm a real nerd who read the book. Okay, this is called the combustion reaction. You're going to learn types of... What?
We both read all the books.
I know, I read all the books. I think every summer when I was
We should
in
start a
school.
club.
That's a long story. Combustion reactions, you're going to learn how to identify reactions probably later this week. This is called the combustion reaction. And there's one trick for these, and that is whenever it's a combustion reaction, which just, you'll notice, has C's and H's and O's. So something plus oxygen makes carbon dioxide and water. Balance these alphabetically. Alphabetically, okay? So that's one trick I can tell you for, this is for combustion reactions only. So if it just has C's and H's and O's, balance it alphabetically. One tip I will give you. Okay, let's balance this alphabetically. What is the first letter that comes in the alphabet order sequentially? Yeah, carbon. Okay, so we've got 2 carbons here. How many carbons do we have here?
Just one. So put a two.
One.
1. So how do we fix that?
Two.
Put a 2 in front of
On the
it.
product
Okay.
side.
Now, as I said, that 2 would give you 4 oxygens, but let's leave oxygens last. So let's bounce back to hydrogen here. I've got 6 hydrogens here. So how do I get what I'm
3 on the product side.
So 3, because 3 times 2 is 6, right? But that presents one more problem. Now, the reason you can do this alphabetically is that you can total up all the oxygens you have here, and you can put a number here and it doesn't affect anything else. So how many oxygens do I got? Well, I've got 2 times 2 is 4, plus 3 out here, right? So 4 plus 3 is what? Yeah, I was unsure of myself. It's 7, okay? But, so,
3.5.
yeah, I would put 3.5 here, right? Because 3.5 times 2 is 7. The problem is that no one likes to have fractional numbers in the formulas or in the balanced reaction. So the way you fix that is you just double everything. This is like the hard, one of the more challenging ones. So instead of having 1, 3.5, 2, and 3, you just double the whole thing and say, okay, let's do it 2, and then I'll use my magic eraser.
4.
7, 4, and 6. Okay. The thing about balanced reactions, they have to be lowest whole number ratio, sort of like you had in the last test. Okay. And this is still the lowest whole number ratio. You can't reduce any of these numbers, but you can't have the 3.5 there either. Okay, so that's how you fix that problem. Missing stuff. Should we keep going? This is so fun. Want to have another one? Let's get crazy, right? What?
I have homework for my next class.
Yeah, we
too.
can do homework.
Let's just try one more for funsies. I think there's some things that I'm missing, but I can't remember what they are, so I'll just keep going. Let's make something up. Okay, you try this one. Looks complicated, but remember you should treat polyatomics as one thing. So polyatomics, so this guy right here is one thing, this is one thing, the K is one thing, and the MnO4 is one thing. So the ones we want to have balanced are NH4, PO4, K, and MnO4. Treat those as 4 separate entities, okay? Try it right now while I go help the test takers.
What's glycerol?
I don't even know what it is, it's the worst one.
Fancy. Write it down, Mark.
Yeah,
You're supposed to write 3 to 1.
Oh no. Why would I write this down?
3. 3 there. No, yes, again.
Oh yeah, no, they're fine.
We don't have 3. Oh yeah. Wait, no. Oh yeah, 1.
What? True.
Wait, no, 1, 3. 1, 3. 1, 3. Yeah. I knew there was 2 ones and 2 3s.
Yeah.
take another 30 seconds or so.
LMNOP.
STU.
Whose name is in the
Yeah,
alphabet?
Stu's name is in
Okay. Again, you're treating these 4 things as, these are the 4 things you care about here. Okay, so treat, even though it looks complicated, remember there's only 4 numbers you're going to write down in front of those 4 reactants. We're treating those polyatomics as one thing. You can start in a couple places. I tend to start at the beginning, and I notice right here that I've got 3 ammonium ions right here. How many do I have right here? 1. Okay, don't be confused by the 4 there. That's really just one of them. So I'm going to fix that by putting a 3. But the 3 distributes to everything. So while I fix this problem, I create another problem. So now I've got 3 MnO4s. And I've only got 1 MnO4 here, so how do I fix that problem?
Put a 3 in.
Put a 3 of it in front of it. And that gives me 3 Ks, and I've already got 3 Ks, so I'm set there. And I've got 1 PO4 here and 1 PO4 there. Notice again that you're only putting numbers in front. Don't mess with the formulas at all. Parentheses, subscripts, don't touch. Cool. I've got one more. One last thing I haven't showed yet. And that is, sometimes it's not as simple as putting a number in front, and let's see if I can make one of these up really quick. Okay.
Oh,
AU.
I got it. So it's all right.
Just give me, let me think. Let me think.
Why do I always mix them up?
Look, because the back, like the 3 is kind of leaning back.
Magnesium fluoride.
You want to call it ankle? It's an U though.
Well, but it looks like an N.
Is that
And if you change the C to a K, it'll look just like an. No.
Yours is not silver. Dang it.
Silly.
Wow, this is exciting.
This is fun to watch me do this, right?
Yep.
I'm enjoying myself.
Ooh.
Is AU silver or gold?
It's gold.
Gosh, David.
It's gold. Sometimes it's not as simple as putting one number in front. If you just take a look at these really quickly, the gold and the magnesium, these two are fine, right? One gold here, one gold there, one magnesium here, one magnesium there. But the 2s and the 3s are what we need to fix, okay? When you have a problem like this, you have to, like for example, let's just look at chlorine, since it's in the first group here. Chlorine, there's 3 of them, and there's only 2 here. You have to get them both to a common number, okay? And so there's no easy way to get, a 3 and a 2 to balance out, but we can do that if we get them both to what number would be
6.
common to 3 and a multiple 2 and 3, yeah, it's 6, right? So to get this to 6, I'm going to put a 2 out front here, and to get this to 6, I'm going to put a 3 out front. And then if you go look to see, okay, well now that gave me 2 golds, and so I'm going to go put 2 golds here, and that gives me how many fluorides? 6. And so I want to get this to 6, I put a 3 out here, because 3 times 2 is 6. And that gave me 3 magnesiums, and I've already got 3 magnesiums. But notice the first part was a little bit different, because we had to kind of get them to a common multiple first. Any feelings about that? Questions about that?